Welcome to the KuppingerCole Analyst Chat. I'm your host. My name is Matthias Reinwart. I'm a senior analyst and lead advisor at KuppingerCole Analysts. And I want to invite my guest today. My guest today is Alexei Balagansky. Hi, Alexei.
Hello, Matthias. Thanks for having me again.
Great to have you again, and great to have you for the first time in video format so that people can associate a face with the voice. Great to have you. Today we want to talk about a cybersecurity topic, as you are covering cybersecurity as one of your main areas of expertise. And we want to talk about a technology that is actually quite old, that is actually quite well used within many organizations. Of course, in the internet, we want to talk about the domain name system. We want to talk about DNS. And as I mentioned, this is really a long time around. Why do we want to talk about it? But first of all, what is it?
Well, first of all, thanks for an opportunity to talk about this topic, as you mentioned, DNS and DNS security in particular. And yeah, this is exactly one of those topics which been around so long that people just kind of don't think about them anymore. Either they just kind of put it into the farthest corner of their mind, or they foolishly think that all of the security problems with DNS have already been solved, which is not the case, and this is exactly what we are discussing today. But first, I guess we have to give a short reminder of what DNS actually means and why is it important, right? So DNS, as you mentioned, means domain name system, and this is one of the foundational core services powering the internet. This is a service we use every time we want to connect to a website or open any named resource on the internet. Basically, to turn a name, a URL, like for example, www.kuppingercole.com, to an IP address to connect to access our corporate website. So yes, DNS is one of the oldest, most important internet services. And since it's one of the oldest, it's probably one of the least secure ones. And unfortunately, it's been around so long and so ingrained into the backbone of the internet that you cannot just throw it away and replace it with a better secure one, right?
Right, I got it. So when you say it's been around for a long time, and it's not necessarily designed from the beginning to be secure. When we talk about the security of the DNS, and as you said, it's one of the powering infrastructures of the internet. I assume that it's constantly under attack. And which are the areas where we should think of security and maybe other aspects when it comes to DNS? Where is DNS at stake? Where it's endangered?
Well, again, I guess it would be important to remind that kind of DNS as an infrastructure is strictly hierarchical. It means that if I am currently at home and I want to connect to a website, let's say google.com, first my computer has to call the DNS server built into my home router and ask what's the IP address for google.com. If the router doesn't know, it would kind of relay my request to the DNS server of my internet provider, and that one would go even higher until it reaches the top level domain DNS server, which is responsible for the first top domains like .com, for example. And the top level domain server, the domain name server, will refer back to the one which is responsible for google.com, the authoritative server, and that one will give me the final result. Now I know how to connect to Google. And there are so many steps in between, and all of those steps are absolutely in the open. They're not secured, they're not encrypted, they're not protected from snooping or manipulation, which is why anyone can act as a man in the middle. It can see which sites I'm accessing. It can manipulate the DNS server, exploit a weakness or unpatched vulnerability and give me the wrong IP address. Or a hacker can simply set up a domain which would kind of, to my eye, look like google.com, but in reality it will be something like Google with the Cyrillic O in the name, and it would lead me to a totally fake and malicious website. There are many different security and privacy related problems with DNS, and I guess privacy-related DNS problems would be a topic for a different discussion. So today we'll just kind of go through a list of the most important security problems.
Right. So on the one hand, we try to, or we have to trust the service. So this is this security issue. And on the other hand, we present lots of more or less private, personal, secret information to this simple mechanism just by typing in a website, by connecting to a mail server, because we just disclose the address or the name of the server we want to contact. So it's, as you said, it's security on the one hand, it's privacy on the other hand. Let's focus on the security side of things and pick up on the privacy issues in a later episode. So where is this where's one of the key security issues when it comes to talking to DNS? You've mentioned the spoofing of IP addresses. Is this really a thing today?
Well, first of all, there is this kind of manipulating the domain names. Basically, again, you just register a domain name which looks like a legitimate one, Google, Microsoft, KuppingerCole, but just uses a different spelling, or like one instead of an I, or a Cyrillic O instead of a Latin O. And basically, you can just forge a link which would look nearly perfect like the real one, but would lead a user to a totally fraudulent server where they can just use a standard phishing or manipulating techniques to, for example, kind of make the user to type in his password or his credit card number, whatever. This is like the most obvious type of exploit. Everyone is mostly talking about those. But those are more or less, well, I would not call them solved, but at least I would say this was one of the least concerns, because, traffic encryption is now prevalent, and every SSL certificate, a TLS certificate, usually comes with the domain name hard-coded into it. So you would notice if you're connecting to a different domain name, right? Or every modern browser would highlight a domain name which looks suspicious, like, for example, if it mixes different writing scripts, you would immediately see it. But this would really mean that the awareness of the user, understanding what this sign in the browser, in the browser address list, what that really means, that this address is not what you expect it to be. This is also part of the protection. So on the one hand, it's the browser being so smart to realize it's not the right address that you're connecting to, but it still requires the awareness of the actual user. So training is in that area also, again, very important, getting the people on board and making sure that they understand what this actually means, that this is not the right address. So it's technology plus an intelligent user. But for other attacks, what others are there? Maybe not that common ones. One interesting aspect of DNS security, much fewer people even know about, is DNS exfiltration. Because DNS is an internet service, so it requires an open port number 53, and this is one of those services which has to work everywhere. So this port is usually open on every firewall and in every network, just like the HTTP port for the websites. Like, everyone needs DNS everywhere. And hackers, when they get into a network and they need to exfiltrate sensitive data, sometimes they rely on DNS exfiltration, which means that they encode the data they want to steal into DNS requests, and they would connect to their fraudulent own DNS server and imitate it as like, it would look like you just kind of trying to connect to a non-existing website. And of course, your firewall would block that connection to the website, which doesn't exist anyway, but it will allow through the DNS queries. And those queries would be used to exfiltrate your sensitive data. And this is extremely important, that your firewall or intrusion detection or whatever network security solution you have in place also understands how to deal with DNS exfiltration. Another totally unrelated aspect would be denial of service attacks, for example. One interesting quirk of the DNS protocol is that a reply to a DNS request is usually much larger than the request itself. For example, I could just send a packet to a DNS server, a totally legitimate, unmanipulated one, and ask like, tell me everything you know about google.com. And it would return me lots of data because Google has obviously a lot of host names and additional information. What I could do at the same time, I could forge my IP address in that packet. And instead of sending that reply to me, the DNS server would send it somewhere else. This is called DNS amplification attack. And if you create lots of tiny DNS requests with forged source addresses, it would mean like a deluge of DNS responses on an unsuspecting website, for example. This is not as popular as or other types of distributed denial of service attacks, but it's much more difficult to mitigate. This is just kind of a few kinds of different, totally unrelated to each other DNS attacks because they exploit different aspects of DNS's infrastructure. And probably there is no single tool which can fix all of those challenges at the same time. That's the biggest problem.
Right. And when we're talking about security, of course, we also want to have a look at what actually helps in mitigating these requests. And we've looked at these attacks. We've already looked at this mechanism of using encryption and SSL certificates for this DNS spoofing attack. What are the technologies that are in place to protect organizations and end users from the attacks that you've mentioned? So, for example, this data exfiltration attack sounds really scary because you're exchanging the payload and you're transferring data outside your own network using an infrastructure that needs to be open, which is the DNS system. What can organizations do to protect themselves from this mechanism?
Well, the problem is, again, in that you cannot just buy a DNS security tool like you would buy an antivirus tool. Because all those different attacks, they are almost unrelated. They have the only common thing in them is that they exploit weaknesses in DNS. Of course, like, for example, the easiest manipulation, which is probably very seldom on a desktop computer, but much more popular on a mobile device, it's just kind of replacing your legitimate DNS server with a fraudulent one. So every time you try to open a website, it would resolve through hackers manipulated DNS server and lead you to a different website. The only way to mitigate this type of attack is to have something on the same mobile device which would ensure that your DNS setting is not manipulated. So you would need some kind of an endpoint detection and response, or at least an antivirus on your smartphone, right? If you want to prevent DNS exfiltration, that alone would not be enough. You would need, first of all, to be able to detect this type of exfiltration. So you would have to sniff all your network traffic and understand that the patterns of DNS traffic flow look suspicious. So you would probably need some kind of machine learning based behavior analytics solution in place, which would detect those kinds of anomalies. If, for example, you want to prevent so-called cache poisoning attacks, which basically make a legitimate, like your own corporate DNS server to return fake responses, well, you would have to ensure that your DNS server as software has no open vulnerabilities. So it's patched, it's maintained properly, it's secured. So for that, you would probably need some kind of a managed security service, right? Or you just have to ensure that your own IT team knows how to deal with those types of attacks. So again, there is no turnkey solution for all types of DNS-related problems. You have to be vigilant, you have to understand your risks, you have to basically understand the potential impact of different risks on your infrastructure and make appropriate purchasing decisions.
Right, and when you've mentioned that when you run your own DNS server, and there are good reasons to do so. For example, when you are in a corporate environment, still that old perimeter-based security and an inside and an outside of the network, you want to give names to your inside services as well. So you do have to run a DNS server and cannot just rely on external ones. So one good idea and one recommendation from our side would be really to make sure that there's a proper patch management tool available that makes sure that the DNS software is always up to date, and that you add the additional security mechanisms that you've mentioned. Are there any other maybe also services that are available around that can add additional layers of security? You've mentioned this machine learning mechanism that can detect anomalies in the behavior of a DNS server, or at least outliers, unexpected behavior. Is this a market? Are there vendors that provide these services to protect your DNS service?
Well, obviously there are specialized security solutions which focus on all aspects of network security. Nowadays, they probably called NDR, like network detection and response. Of course, they will detect those DNS-based attacks and all other types of attacks as well, because they basically sniff all your network flows and understand if something's not working as expected. Another potential solution would be just to basically invest in a commercial DNS service. So instead of relying on public DNS software running somewhere outside or running your own DNS software internally, you could just outsource it to a managed DNS provider, basically. It's probably not entirely a SaaS-based solution because you still need some infrastructure to run, but it will be infrastructure which is managed, monitored, patched, whatever, kind of operated reliably and securely by a qualified third party. But of course, the most interesting for us as a security-focused analyst would be something like, you've probably heard the term SASE. Everyone is talking about SASE nowadays, Secure Access Service Edge, the idea of delivering a full security stack from the cloud. And one of the underlying technologies would be to deliver a SASE stack based on DNS security. The idea is that instead of using your own DNS server or a public one, like from Google, for example, you would simply reconfigure your devices to, let's say, a Cisco umbrella service, and they take over your DNS management and they ensure that every request to a DNS server which goes from your infrastructure, from your devices, is double and triple checked on the fly, that if it's known to be malicious, the connection will be intercepted and, for example, routed to a cloud-based sandbox, and the payload will be exploded and monitored for malicious activities. And if it's somehow detected to be malicious, it will never reach you. It will be intercepted and blocked. And all of this is done through just basically manipulating your DNS setting. It's like that hacking attack I mentioned earlier on your mobile phone, but with the good guys on your side, so to say. And of course, if you deploy it centrally and you manage it properly through some kind of policy enforcement across different landscapes, like IT deployments, mobile devices, desktop devices, inside the office or working from home, if it's done properly, if it's monitored, it's a great opportunity to reduce your overall costs on cybersecurity.
Right, but on the other hand, you have to, on the one hand, trust this provider of this SASE service, and on the other hand, once something happens to this SASE provider, this would be the bottleneck for your complete infrastructure. So you hand over responsibility, you hand over the patch management and the level of quality over to the service provider. So this decision must be really well done, and it might require some additional measures to add levels of control to make sure that you are protected even in the case of an event at the SASE provider. Is this something that you look at as well? Are there attacks running especially against these providers?
Well, on one hand, you are technically absolutely right, and there is a lot of people who I would say, kind of share the same view and general outlook on handling your security controls to somebody else, because it goes essentially against the whole idea of the internet being decentralized. I mean, originally, in the times of DARPANET, it was designed to withstand a nuclear attack, right? So if a part of the infrastructure would be completely physically destroyed, the internet should continue working. Nowadays, it's no longer the case with companies like Cisco or Google or Cloudflare, for example, which handles security for millions of domains and websites. If those companies go down, even for a second, like half of your internet resources would be unavailable, right? So yes, this is a possibility, this is a risk. But I would argue that the risk that Cloudflare goes down is much, much lower than the risk of your own corporate network going down, simply because they have the advantage of scale and centralization. They ensure that the infrastructure is always patched. It doesn't have bottlenecks and stuff like that. So yeah, problems happen, but you have to weigh the balance between the probability and the impact of those problems.
Got it. So you've mentioned that there are different types of tools and different types of service providers that can help you in mitigating risks that are related to DNS. Before we close down today, is there some recommendation when it comes to reading documents on our website or blogs or looking at videos? Are there some recommendations from your side when people aim at protecting their often overlooked, as you mentioned, DNS infrastructure?
Well, I would give like two different recommendations. First of all, every person who is responsible for IT infrastructure management or security just has probably to learn a little bit more about DNS. Because there is an old meme among sysadmins that whenever something happens, the first thought is like, it cannot be DNS. The next step after a few hours of debugging would be like, it was never DNS before. And the next day it's always, it's DNS again. Kind of DNS is still one of the most kind of serious and often happening problems in network infrastructure. So just kind of learn more about DNS, how it works, why it works that way, what kind of attacks are possible, what kind of attacks are kind of trending nowadays. This would be like the key recommendation. And of course, after that, just kind of read more about possible mitigation problems. And for that, we as analysts can offer quite a few reading material on our website, especially focusing on those popular cloud-delivered security topics, like SASE, for example.
Okay, great. So start with the appropriate O'Reilly book about domain name system as the basis, so that you know the gory details, and then look at how to protect these solutions as they are running on your prem or as provided by a cloud provider who does this for many organizations. So as mentioned, we will dig a bit deeper in another episode into the privacy aspects of DNS.
Absolutely.
So that we have today learned a bit what DNS is. So resolving names on the internet to technical addresses. We've learned about the security implications, or some of those, and how to solve them. And I'm looking forward to meeting you, Alexei, again virtually via camera for a second episode, and we will talk about DNS privacy. For the time being, thank you very much, Alexei.
Well, thank you, Matthias, and goodbye.